Today's lecture is continuation from the previous class. Previous class we already finished on arrow diagram. Arrow diagram is part of network diagram. So now we want to zoom in into AON and eventually finish up the PDM diagram. Okay. Next week, I will basically demonstrate the use of Microsoft Project. At the end of the class, you will need to duplicate or basically do the work program based on the given data. Then basically you need to submit. So meaning to say you need to install Microsoft Project in your computer. You can get that thing free, download for specific timing. Or you can go to the YouTube. Some of the people do share how to download Microsoft Project. Or you can buy keys from so-called Shopee or whatever. And then you can run the program. Okay. AOA diagram and subsequent AON diagram and subsequently PDM. Okay. PDM diagram. Well, critical path method. We already covered critical path method. Critical path method is the calculation method in order to generate, okay, in order to generate what? To generate so-called critical activities, and subsequently we can generate critical path. That is the most important things. And then we can always also calculate total float, free float, so that we can basically analyze the impact of delays to subsequent activity or eventually to the overall project duration. Critical path method is the calculation method to derive those things. And then we can use network diagrams such as AOA and then AON and subsequently PDM. So critical path method can be applied into this concept. As we already mentioned many times, we do have Gantt chart by Henry Gantt way back 1910, and then AOA diagram was being developed in 1950s. This is AOA diagram. Subsequently, PERT diagram was developed after that. Then come so-called AON diagram, early 1960s. And then in 1964, from AON diagram, they developed so-called PDM. So PDM is an enhanced version of what we call AON method actually, okay? The why PDM is very special due to the fact that it does have extra relationship other than finish to start relationship, which basically we use in AOA and AON diagram. Remember, AOA diagram, AON diagram use finish to start relationship only because that was the basic. And then subsequently, when PDM was being introduced, additional 3 more relationship was being introduced, including the lag, LAG. So that's what makes this PDM diagram special and eventually being used in current software like Microsoft Project and Primavera. If, for instance, you just learn PDM diagram, that will be sufficient enough, okay? But for academic purposes, we do introduce a bit of background so that you understand the whole story of scheduling development. Okay, essential technique for using CPM, or in our case, we want to develop a network diagram, so-called. For sure, we must have list of activities. How do we get list of activities? From our WBS. Okay, WBS, work breakdown structure. We break down the work according to a small portion, so that we can attach quantity to those small work. At the end of the day, we can manage. In management, we cannot manage something which we cannot measure. See? So that's why management do break things apart in order for us to attach some quantities, so that at the end of the day we can measure in terms of performance, KPI and whatnot. And then duration. We already mentioned duration. How do we generate duration? Based on previous experience or previous project. Okay, but even that previous project can be just simply used as a guideline only. You need to do modification because things do change according to time. And then based on data, productivity data that you kept in certain database, so that you can use again and again. Even that thing need to be modified accordingly, but at least it is better than not having any data. Then dependency. Dependency is the logical relationship between activity. Okay, what come first, what come next, what can be done concurrently, or what are the activity that have to be delayed a little bit in between the finish and the start of the following activity. So those what we call logical relationship. Okay, so the idea of critical path is basically to know what are the critical activities. The critical activities, for simplicity purposes, we can define when total float equivalent to 0. So those activities are critical. What are the critical path? Critical path is basically the longest duration within available path, okay, in that network diagram. And it could be more than one. It is not singular. It is multiple critical path. But in our example, because we only show not many activities, normally the critical path was shown is only one. But in reality, it could be more than one. Okay. And non-critical activity, when total float do have values such as 1, 2, whatever values, then that what we call non-critical activities. Okay, non-critical activity will not form critical path because that activity can be delayed. Can be delayed meaning to say you can play around with the start and finishing within the allowable total float values. Okay, so once we use critical path in our network construction, okay, either AOA, AON, PDM diagram, then basically come the application. Okay, the application we will learn in the second half of the semester anyway, but since it is in this slide, we can basically go through. Enter shorter original duration. For instance, let's say you have a long duration of activity, and then that activity will be connected with another subsequent activity. But what if you do that, if that activity take longer time? So meaning to say, the following activity have to wait for the rest of the activity to be completed, which sometimes might not be necessary. For instance, if you are plastering a wall, for instance, the wall could be very long wall. If you do that, then painting will start after the completion of plastering. But just remember, because it is long wall, you can start painting at the beginning of the wall where everything has been dried up without having to wait for the rest of the wall to be completed. So we can basically split those things and then basically connect this activity to the painting work, and the painting work also have to be split because painting normally could finish much earlier, very fast compared to the plastering work. Okay, if resources are assigned to activity, reduce the duration of these resources or increase number of unit. Okay, for instance, the duration of certain activity, short or long, very much depend on resources. Let's say for this activity for 4 days, you require resource of 2%. But then if you increase resource to 4%, for sure you can shorten this activity. That is how we play around. Okay, we play around, especially when we are running late in terms of completion. Let's say our project is supposed to be completed within 1 year, but then we do have COVID situation, which has eaten up our few months of unproductive time. So the remaining time, basically, we need to do everything, almost do everything in the remaining time. So we need to do this kind of strategy. Okay, put more resources. Change appropriate calendar time. Okay, the one that I showed you before, when we calculate at the end of the network diagram, we are going to have the overall project duration. The overall project duration that we get from the calculation is working days. Okay, is solid working days without the holidays. Let's say, for instance, our overall project duration is 20 days. Okay, but then if we do have holidays in between, as we are the one that basically decide we are not going to work on Sunday because of the labor law and because of certain festive season, because certain hari raya, whatever, if you open the office also, people will not come. So it is better to close. And then you need to pay more, double or triple time. So it is not necessary. So sometimes because of all those holiday taking into account, your project will be spent not only 20 days, but could be 30 days. Okay. But the real work for the project remain 20 days, but except the other day basically could be the holiday. Okay, so holiday is the one that we set. Is it necessary when time is running out, for instance, you might scrap the holiday, you might basically work overtime, etc. And then you start relationship. This is where basically different relationship can shorten our overall project duration. So we are going to see this thing in PDM diagram later on. Divide long activity into several shorter duration. We already covered this thing, similar to the first concept, etc. Since all projects change on regular basis, CPM allow continuous monitoring of the schedule. Why? Because everything is interconnected, then basically you can see the impact right away. Okay. Allow the project manager to track critical activities. Yes, CPM, that is a function of CPM. You can identify critical activities, especially when you want to prioritize the work. You have to decide to give equipment or to give resources to which activity. Let's say there are two activities running at the same time. One is non-critical, one is critical. So which one should be prioritized? For sure, critical activity will be given priority based on the fact that they do not have free time anymore. If you delay those activities, automatically you will delay the entire project. Alert the project manager to the possibility of non-critical activity may be delayed beyond the total float, those creating new critical path. Okay. You know, non-critical activity, the total float could be 1. But if you already use up 1 day, then basically you don't have any free time anymore. If you delay by extra another plus 1 more day, automatically this activity could be now turned into critical. So let's say initially you do have 1 critical path, but then in the middle of the way, then another critical path was being developed. Then the third one, the fourth one, the fifth one, until all the paths could be critical. And then basically you put yourself at a greater risk, because basically everything has to be done according to the time frame. You cannot basically have free time anymore. So you need to watch out. So critical path method enable you to see those things, because it is being created on network diagram, unlike the bar chart. Okay, you can use nowadays theoretically, fundamentally, what we are learning in our class based on manual scheduling, but then later on in the real world, you are going to use software. Nobody do manual scheduling anymore, because it is very hectic or meticulous work. You need to spend a lot of time. So let the computer do that thing. But remember, computer use the concept of GIGO. What is GIGO? Garbage in. You put garbage input, then basically the output that will be given back by the computer also garbage or rubbish. If you do not know where to pinpoint the mistake in terms of inputting wrong data, then basically you tend to accept, okay, this is the outcome. So basically you have been base your assumption based on the wrong outcome. This is what we do not want. And when we want to learn software, if for instance, among you, there could be 1 or 2 people who will be become scheduler or planner later on. And you know what? If we compare the salary of normal engineer with the planner or scheduler, scheduler basically pay a lot more. Anywhere in the world, scheduler always being paid a lot more. And scheduler, there are not many. In Malaysia right now, we do not practice yet. Each of the construction project should have 1 dedicated planner. Now, we have been trying with the safety. Construction project should have safety and health officer. But even that, we cannot go for full swing yet, because sometimes it is very difficult to get cooperation from even the management team, where safety has been put aside. But when we are talking about planning, because the issue with planning, it involves money. When you can do project faster, for instance, you can save a lot more. For instance, so that could be a good reason where you need to have a dedicated planner for all the construction project. Okay, maybe not for the small project, because you need to pay salary for scheduler. For small project, that's why you as an engineer, you need to know some kind of planning as a basic. Okay, the rest for a big project, they can hire scheduler or planner. But I'm telling you, there are not many scheduler or planner around for the time being. So it is a good potential if you want to zoom your career to become scheduler or planner. Instead of graduating with the same knowledge with your friend, why don't you zoom in your career later on into specific things? Well, it will not take 1 or 2 years. It will take a few years to develop the career, but that will be worse compared to just being a normal engineer. Okay, I would say this we refer to PDM because it is more likely that the three relationship being used in PDM other than the AOA AON diagram. This one is yes. AOA AON, I would agree. Okay, now let's take a look at the other relationship. We already mentioned this thing, but just want to review. Finish to start relationship. Okay, when you draw something like this, either you can look this thing as a bar chart or the AON diagram. AON diagram basically we draw by box. So the left side of this box, we call it start. And the activity will be going on. Okay, will be going on. This indicate as if the length of the activity that is happening in the box. But you can draw the box at similar size. Doesn't matter. I just want you to have some kind of imagination. The left side is the start, and then you will be going on how many days, and then you finish. The right side of the box is finished. And then, immediately after you finish plastering, you will start painting. But you will not start painting on the same day. If you finish plastering at 5 o'clock during that day, then painting will be started on the next day, not on the same day. But for calculation purposes, we just simply, for instance, we start with 0 days. Let's say plastering in 5 days, 5. And then, of course, you say it is 5. Let's say painting is 2 days. 5 plus 2, so you are going to complete the project in 7 days. So that 5 is not meant the same days. It is the following day because that day at 5 p.m. is already a non-working day. It is off time already. So you cannot basically do the work. So whatever the duration that you mentioned here, it basically refers to the solid working days. Okay, working days. Then this is the activity painting. The left side also always we call it start, and then this is finish. So that's why the relationship is taken after this concept. Finish to start. See, this is a type of relationship, and you notice the arrow is coming from where? From the right side of the activity, finish, and then this is the start. You can draw something like this. This is a finish to start. So this is also correct drawing. You can draw something like this. Let's say activity A and B. But then you want to relate them in terms of finish to start. Well, you can draw something like this. You see, this is also finish to start. This is also finish to start. This is also finish to start. You can draw almost everything. You can draw something like this. Okay, A, B. Then this is also finish to start. Because when you draw, the most important thing is this, the where basically does this arrow coming and going into. That is the most important thing. But when you draw bar chart, you have to be very careful. Because what bar chart do have what we call time scale. This is from day number 1 until whatever the end of the project. So when you draw the Gantt chart, you must follow exactly the location of the days. So for instance, between this activity, these basically indicate different thing because at the end of the day, you want to know when is activity B completed. Okay, so because you are based on time scale. But for AON diagram or PDM diagram, you can put your box in whatever position. The most important thing is basically you draw the arrow in the right manners. Finish to start indicate from the right of the box, finish, and going to the following from the left. That's it. Next, start to start. Okay, start to start relationship. Let's say there are two activities, cut and fill. Cut and fill, normally both activities run simultaneously. When you start cutting, and then the excess material will be filled in into the valley. But in this diagram, they could be here. You notice there is a wrong way of drawing, what we call drawing about arrow. There are two activities. Let's say activity cut and fill. They are running at the same time. So start to start, you have to draw something like this. So in terms of arrow, they must be tail and arrowhead. This is the tail and arrowhead. So this two arrowhead could be confusing. Okay. So, but if you connect from another activity, then it is correct. Okay. Let's say activity, what we call clearing. After you completed clearing and then you do the cut and fill. Okay, that if you draw something like that, it's okay. So indicate cutting and filling do start concurrently, okay, after clearing. That is correct. But if you just simply do have two activity like this, then one tail and one arrowhead should be draw properly. Otherwise, people will get confused. Then finish to finish. Again, we can use the same activity, cut and fill. We want to synchronize in terms of finishing, because if we draw something like this, there could be something wrong, because again, two arrowhead is there. We can draw this activity is going, this line is going into that, and with one arrowhead. So finish to finish at the same time. Okay. So regardless of when this activity started, the most important thing is the finishing. And in the case of start, the most important thing is the start. The finishing could be, they could be finished at different time. We don't care. It depends on the duration of each activity anyway. You see, that is the difference. And it depends. Sometimes you might want to use this type of relationship. Sometimes you might want to use this relationship. So it depends on the logic. That's why experience will basically determine which selection of logic basically is accurate one. Okay. And then this is a quite rare or unusual relationship, start to finish. It's the reverse from finish to start. Finish to start is a very common one, but then we do have the reverse. Do people use this thing? Yes. Experienced people, I have known experienced planning manager do use, but if you want to use, you need to really understand or fully understand what this is all about. Otherwise, just simply use start to finish with leg, lead. We can use that. Okay. Example, lay brick. Okay. This is again the reverse. If you want to lay brick, let's say you want to construct column or wall, brick wall, for instance. The start of the, you cannot, when you want to start laying brick, the previous activity must be completed. What could be the previous activity? Brick delivered. Brick is already there. The delivery of the brick has been done or performed. Then only you will have the brick available to start laying of the brick. Just something like that. And then to start the brick delivery, you must complete the procurement. Procurement is the purchasing request. You need to do some kind of order first, then only brick, brick being delivered. Otherwise, you simply cannot. And then the start of procurement, purchasing. Before you start to purchase, you need to have some kind of approval letter from the consultant or the client or the architect. Before you even get your sample approved, for sure you need to submit the sample. If not, how are people going to approve? So normally, if we do that thing, it is like a backward thing. Normally, it is for procurement procedure. We want to know procurement procedure or even quality control procedure, I would say, quality control. But another example, let's say you do have a river, you do have what we call old bridge, where the car is still using this bridge, okay, using the bridge. Then at the same time, you are constructing a new bridge, okay. You are constructing the new bridge, and then later on you need to demolish. The issue is that demolish old bridge. When you can start demolish the old building, you start. For sure, you can only start demolishing the old building prior after the completion of new bridge. When the new bridge already completed here, finished, then only you will start demolishing. Otherwise, where people are going to use the bridge, the new bridge is not completed yet. That is one example. Okay, there could be many that we can use that kind of relationship. Normally, it indicates a very strong relationship where you just simply cannot start the project without having those things completed yet. Okay. All right. Now we already introduced 4 type of relationship. Okay. These 4 type. All right. Then for PDM diagram, there is additional what we call features. Lag time, LAG. Lag, there could be positive lag values, they could be negative. And the negative one, sometimes people call it lead, L-A-D-E. In certain books, they call it lead, okay, so that we can distinguish between positive and negative. What is lag time? Lag is simply basically delay. You delay the starting of the subsequent activity. Or you, instead of delay, the negative one, we call it lead. You move ahead. You start a little bit earlier. Instead of later, you start earlier. Example. Okay, post slab, or you construct wall, you construct floor. Okay. In Malaysia, for instance, we do construct floor, we post slab, wet concrete. Then we need to wait. You see, you notice there is a drawing here, waiting period. If we draw something like a bar chart, say this indicate day number 1, and then maybe post slab will take around 2 days, whereas another 3 days, and then column will be take how many days? Okay, 4 days, for instance. You notice here indicate waiting period. Why? We need to wait for the slab to dry up. This is what we call curing process. Curing time. Even you have been to the lab, to the concrete lab. So when you mix the concrete, then you put into the mold, and then you compact the mold, and then you open up the mold. What happened? Okay, so you wait for the your concrete to dry up. The next day, then you need to open up the mold and put them into water, for instance. What is that thing is all about? That is curing process. Okay, because that is for the purpose of testing. But in construction, it's the same. We are going to let the concrete to dry up, but sometime in between, it will dry up too fast until the crack exists. So that's why we need to cover with a gunny sack we need to basically pour some water so that it basically dry up gradually, and then we are going to have a good quality of concrete. Okay, that is what we call curing process. So we want to indicate you cannot start erecting building a column immediately. We need to wait for the floor to dry up by how many? Let's say 2 days, 2 or 3 days. So you notice, let's say this is 2 days, this column is 4 days. You notice what would happen to the completion of the project. So by calculation, 0 plus 2 equal to 2, 2 plus 2 equivalent to 4. You see? So we start at the day 4, not immediately at day 2, because the issue of we do have lag. Okay? And then 4 plus 4 equivalent to 8. You see? And the way we draw this relationship is Fs plus 3. Plus 3 is the one that indicate lag of 3 days. Why basically we do not make those things as activity? Because curing is not an activity. It's just a waiting period. We better reserve activity to the real activities. Otherwise, our diagram will be full of activities which we can call it unnecessary activities. But in the case of delay, later on when you update the project, let's say delay do happen, you can create activity by the name of delay in order to basically to emphasize that delay is already happened. This is for tracking purposes or monitoring purposes. We do not talk about those things yet. Okay, that will be the subsequent second semester of the topic. Okay, that is what we call positive lag. Okay, you notice that Fs plus 3. Before we go into negative, Fs plus 3, what does that thing mean? Fs plus 3. So we call it, this thing is delay. We delay what? You have to read with regard to this wording. The start of the following activity. This is the one being pushed by 3 days. Okay, so the delay of the following activities, the start of the following activities. So that is what lag is basically referred to when it is positive. But how about if the lag is negative? The way we draw, the way we indicate is Fs minus 2. When people put something like this, then automatically you understand. So this is basically negative lag. So you notice the way we draw, this is like 2 days. We start earlier. So that's why negative lag, I mentioned it is lead. Lead meaning to say, we start ahead a little bit. If it is lag, we are going to push this way. But if it is lead, then we are going to start a little bit earlier. Why? Because remember, the way we draw the diagram is from left to the right. Left indicate beginning of the project. Beginning, then this is the end. So earlier mean we push backward a little bit. So later we mean we push forward. That is the concept. So if, for instance, based on calculation, if negative lead is there, let's say site clearing is 3 days, cutting is 2 days. How would this calculation be? 0. 0 plus 3 equivalent to 3. So nothing is affected with the first activity, but with regard to second activity, you notice 3, you have to minus with 1. 3 minus 1 equivalent to 2. 2 plus 2 equivalent to 4. See, you completed at 4 days. By right, if you just simply, without this thing, you are going to complete it at 5 days, because 3 plus 2 equivalent to 5. So you notice that once we start the following activity a little bit earlier, then we can cut down on the project completion date. That's how we play around. Okay, we play around with the type of relationship in order to compress the project so that it will not be that long. Okay, next. Start with 5 days, like. Okay, start and start. You see, this we have been pushed the starting by 5 days, positive 5 days. If it is without this thing, then these two activities start at the same time. But now the starting of the following activity we has been pushed forward, okay, or delay a little bit. That is the concept. And if this lay break is, let's say, 4 days, 0 plus 4 equivalent to 4, and then 4 plus 5 is equivalent to 9. Maybe plastering is 2 days. 9 plus 2 equivalent to 11. You see, with the lag around, it will affect the calculation of the our activities. That is the for sure. It will affect. Then, how about lay break? Okay, lay break and plastering, finish to finish. Remember, it is the finish is the one that we basically uh, delay. You notice we push back. Okay, we push ahead the finish, the finish of the following activity, because it is plus 5. If, for instance, the activity mentioned -5, -5 meaning to say we are going to push this thing backward. But then you must have two logical relationship. You just simply cannot have a very funny relationship and then try to impose a negative lead and whatnot. It is not going to work because some activity must be done in sequence anyway. Okay, that is the concept. So we are going to apply those things in a PDM diagram later on. Okay. Early start, early finish, late start, late finish. I already mentioned this thing at the beginning of the what we call introduction to network diagram. So AOA diagram, AON diagram do use similar terminology. Okay, do use similar terminology. For instance, in certain activity, we can start as early as possible within the time frame. Let's say the time frame is like this, but then we can work backward to start. This is what we call late start, late finish. This is what we call early start, early finish. Within the time frame of allow, because you must remember, when we put all the activity into a project time frame, let's say the project is running for 2 years, there could be 100 and even 1,000 of activities. And there could be a group of activities belong to certain WBS only. So this is the time frame that we are talking about within the project, not encroaching the overall project duration. Okay. Then what else? Total float and free float is similar. Okay. We can define total float as for either one, AOA and even AON PDM. But PDM is much easier because everything is inside the box. Late finish minus early finish, or late start minus early start. Values of an activity. Okay, but let's say free float is free float FF. The definition is early start minus early finish. But the early finish is the FF is the current activity. Current activity is the one that you want. Early start of current activity. Early finish of the no, sorry. This one, current activity. This one is current activity that you want to figure out. This is the subsequent activity. Subsequent. Then only you will get the right answer. Critical path is the longest duration in the network. There are so many, there could be a few paths. Among the paths, if you add up the activity duration, then you basically can know already. But if there is a lag, lead, you have to take this thing into account. When you calculate, and when you add up the activities, you need to take this thing into account as well. Okay, otherwise, you are not going to get the right answer. Forward pass is the method to calculate early start plus duration equivalent to early finish. You want to get this value. You start from the left until the end of the project. What you are going to get, early start, early finish. You can also calculate free float, because free float formula is just comparing early finish and early start of the different what we call activities. So you can know this thing. You don't have to wait for all the activities. Now I'm telling you, during exam where you do have very limited amount of time, you don't have to calculate everything to complete the network diagram as we do in the assignment or in our class. Because in exam, the exam question will ask only a few questions, very selected question. So from that, you just focus to calculate on that particular activity. Then you will get the answer. Don't complete all the network diagram. You are going to waste your time. And then for sure, you are going to get the overall duration. Backward pass is the calculation from the right until the beginning. What you are going to get is basically you are going to get late start equivalent to late finish minus duration. And remember, for forward pass, you take whichever bigger value. When there are connecting arrow that goes into the what we call nodes. And for the backward pass, you take the smaller, or basically the smallest value among many backward, basically going back arrow, the smallest, or this one is the biggest, if there are so many. Then you can calculate total float. For total float purposes, then basically you need to have all the values, otherwise you cannot calculate. Then critical path. Critical path is defined when total float equal to 0. Then that indicate that activity is critical activities. When critical activities are interconnected, they are called critical path. Okay, network diagram. A good network diagram is when you see everything is connected. You see everything is connected in terms of arrow. You do not left one or two activity hanging just like that, even though it is not wrong. But the idea of network diagram is to generate critical path. Okay, so when you want to generate critical path, when you have everything is connected like this diagram, where you can start what we call start is a milestone diagram. You can add start, even though it is not given, but you can add a starting what we call activities, because start doesn't have any duration. It is 0 duration, but since it normally being put at the beginning and at the end, especially finish, so that's why we call it milestone, important event. Milestone is what we call important event. You can add this thing. You don't have to add. It is not wrong, okay, because you will get the answer also, because whichever the highest value, let's say this is 20, this 20 will be put inside here. So the answer is also 20. 20 plus 0 equivalent to 20. So this is the end of the project. Similarly, it's coming from that things. Okay, but for what we call to complete the network diagram so that it looks nice, so you can add start and finish relationship. Okay, example. Um, First thing first, we need to come up with the list of activity. So start and finish is there. Then we name the activity, but for our academic purposes, we simply say ABC. And you notice the task ID number. ID number, it is not necessary when you list something like this, but when you do Microsoft project, you will notice the ID will be auto-generate with regard to each of the row that you input your activities, and Microsoft project do not recognize by the name of the activity. Microsoft project or even Primavera do recognize activity by the ID. So that ID is auto-generate. Okay. So when you input the data into Microsoft project, when you want to do the predecessor, it is not based on the activity. It is based on the ID. For instance, A. A is connected from start. So what is the ID of the start is 1. B is connected from A. What is the ID of A? 2. You see, this is the right predecessor you put into Microsoft project. You do not put based on what we call name. All right, but for learning purposes, we do that. Okay. Now, next step is basically to draw the diagram. You already know you have how many box. Okay, you can draw the box very quickly. Okay, and you can put the box everywhere that you want. The most important thing is the connection. Okay, but the drawing that we show you looks very nice. If you draw by yourself, when you put the box not in the order, then basically the arrow could be you could have intercepting arrow or arrow that could be tangling. There is nothing wrong. Okay, the arrow can be crisscross. There is nothing wrong unless you connect them wrongly. Then it is wrong. So start activity milestone. Then you notice go to the list. You notice start activity. Start is here. Start is here. So there are two activities, A and E. The predecessor is start. You see, A and E. So the connection is from the start. So some people would put A here, whereas some people could be putting E on the top of the diagram. It doesn't matter. There is nothing wrong. But then you will see the diagram could look different, but in terms of relationship, it is correct. That is the most important thing. Then you put A. Then what else? You go down the list again. How about B? B is the connection from A. Okay, so you draw B, then you just simply connect from A. Then what else? C. C is from B. So B is already there. You just draw C and then you just simply connect. Okay, now you completed A, B, C. How about D? D, C, and H. So you know C is here. You just simply draw. You can draw up here D because you never know how to connect. Something like this. Okay, but since we already have those things, you draw D and then connect one line here. Okay, and in terms of the drawing, the line that you connect here, the arrow, don't have to be straight line. You can have a curly, see, arrow. There is nothing wrong. Okay, or you can have zigzag, like that. It is also correct. Okay, the most important thing, where does the arrow coming from? Where does basically it goes? Then you connect the rest. Okay. All right. Next, compartment. Compartment meaning to say what to put inside your diagram. Okay, inside the diagram, you need to basically draw a legend. I normally draw a legend like this because everything is there. Duration is here. This is early start, early finish, late start, late finish. I put total float here, but free float is not. We can put free float here. FF is free float, not FS is finish to finish. Finish to finish is the relationship. Then what else? The activity is here. Everything is inside the box. You can do that. But since we do not have the space, here we just indicate ES at the top there. Okay, now we do the forward pass. You see, you notice? Forward pass. Forward pass is basically you add all up from the beginning. Add everything, add the duration with early finish. So you start with 0, 0 plus 0 because the duration is 0. 0 plus 0 equivalent to 0. That's why 0 is being there. Then transfer into the box because the relationship is finished to start immediately. So 0. Then you need to calculate everything is inside the box. Don't get confused with AOA diagram. AOA diagram is here. This indicate an activity. So that's why when you calculate 0 plus 7 here, then you put 7 here. Because this indicate an activity. But now you have to set your mental right. The box indicate an activity. So everything happened inside the box. So 0 plus 7 equivalent to 7. Then transfer here because finish to start. 7 plus 6 equivalent to 13. Transfer here. 13 plus 3 equivalent to 16. Okay. And then when there are two arrows going into a box, then you have to take a bigger value. This is the concept of forward pass. But we need to wait from the bottom of the box in order to evaluate which one is bigger value. So we need to resolve this thing first. D. 0 plus 3 equivalent to 3. 3 transfer here, and also 3 transfer to another box because there are two arrows going into different box. 3 plus 3 equivalent to 6. 3 plus 2 equivalent to 5. And you notice there are two arrows going from this box into D, and now we need to evaluate between 6 and 5. For sure, 6 is the bigger value. We put it here. 6 plus 2 equivalent to 8. And between 8 and 16, which one should be considered? For sure, the bigger value will be there. 16 plus 4 equivalent to 20. Now you already have the overall project duration. You already answer one question. You can also calculate total free float. How to calculate free float? Remember, free float for, let's say, here. The formula of free float is basically you compare the differences between this value and this value. For example, total float for F, you compare between subsequent activity. So 6 minus 6 equivalent to 0. You put it here, free float. How about G and H? G and H, you compare this value. 6 and 5. 6 minus 5 equivalent to 1. Meaning to say, activity G do have free float equivalent to 1. Because the starting of H will start on day 6, whereas activity G already finished on day 5. So activity G do have one free float that he can play around. If, for instance, happen to be delay, or we want to delay the starting of activity G instead of start at the third day, why don't we start on the fourth day? So we can still basically catch up with the subsequent activity. And that is the concept. Then backward pass. Backward pass, you notice this is the last value. You just simply copy back into this value. This indicate as late finish. Late finish minus duration is equivalent to late start, because this is the one that we are going to calculate, but within the box. Okay, 20 minus 4 equivalent to 16. For sure, you are going to get the same value because it is coming from the same line anyway. And then this 16, you go back through this line, go backward. So 16 is here, 16 is here. Then minus everything inside the box. 16 minus 3 equivalent to 13. 16 minus 2 equivalent to 14. Okay. Then you see, you notice for F and G, there are two activity going back here. So 14 is here, 14 is there, and then within the box, 14 minus 3 equivalent to 11, 14 minus 2 equivalent to 12. Now there are two arrow going back here. You notice there are two values that will be chosen among them. So we choose the smaller value, 11. 11 minus 3 equivalent to 8. And then for B, transfer 13, 13 minus 6 equivalent 7. 7 transfer here, 7, 7 minus 7 equivalent to 0. And 0, between 0 and 8, which one is the smaller value? Actually, it's 0. So 0 will be going back here. Remember, how do we start? 0 plus 0 equivalent to 0. 0 minus 0 equivalent to 0. Now, we start with 0. We go back with 0. That is the checking. Okay, the checking. So now we already completed all the values, which then we can calculate another one, total float. Total float is this formula. We can use this formula very fast. So this formula indicate what? You can just simply the differences between the bottom value and the top value, either on the left side of the box or the right. This is the right, this is the left. You just compare 16 minus 8 equivalent to 8. 14 minus 6 also equivalent to 8. It must be the same unless you make a mistake in calculation. Okay? So that is how you calculate total float very fast. In the exam question, we don't have to calculate all, but for critical path, if you cannot see the critical path based on the diagram, then you can do the calculation. And you notice that the critical path is very easy to notice. Once everything is the same, you see, you notice these same values. So this indicate this line is basically the critical path. You don't have to calculate total float because they will be equal to 0. And the rest, which have the differences in terms of early start, early finish, late start, late finish, do have total float values. Okay. Now, perhaps if you take a look closely at this sample, maybe you will understand the meaning of total float. Okay. You notice this is the critical path. Okay. Critical path normally we indicate with red or whatever, you can highlight those colors. And what happened if, let's say, activity B will be delayed by 1 day, 1 day only. Instead of 6 days, this activity requires 7 days. So extra 1 day plus 1 day. What would happen to the project? Automatically, when you do the calculation, you don't have to. You see, you notice this thing will be extended by also 1 day. So that's why those activity we do call critical activity, because they are the one that determine the overall project completion, unlike non-critical path. Non-critical path, for instance, activity D, activity E, F, H, and G. There are two paths here. Actually, in this diagram, there are path number 1, path number 2, going through E, F, H, D, and the third one is basically path number 3. And what happened for path number 3, if I delay activity, let's say activity H by 1 day, what would happen? Instead of 2 here, I add another 1, 3. Actually, the only changes will happen to the completion of H, but it will not affect the starting of the following activity. When it is not affected, then the project will remain 20 days, you see. So that is why we call it, they are non-critical, because they do have extra time that they can be delay a little bit in terms of starting, or they can start as early as possible, they can start as late as possible, that is the maximum, or they can start in between. But you notice one thing, 888, activity E, F, and H, it does not mean that those three activities do have free float of 8 days and then plus 8 days plus 8 days. No, no, no. They are 8 days, meaning to say they have to share among themselves within the same path. For instance, let's say this activity delay by 2 days. This activity delay by 4 days. You see, 4 plus 2 already 6. This activity H can only be delayed by another 2. In total, it is equivalent to 8 days. If you do not believe me, you can add the new duration, then you calculate. They will be equivalent to 16. So 16 is, see, the same duration. And automatically, if you do that, then another critical activity, critical path will be added. This one is critical path. Even this one is also critical path. Now it becomes critical already. That's how certain path can be turned into critical if, for instance, we delay certain activities. So that is the function of total float and free float. We want to know the impact. Either it could be to the overall project duration. Total float is always being referred to the overall project duration, whereas free float is only in between activities. In between activities, the starting or the following activities. Okay, so that is the end of introduction to AON diagram.